All right, new day, new laptop that needs to be saved. And this time we got an Alienware M16R1. This is one of Dell's newer higher-end gaming laptops. This was sent in to me because they're getting a power rail failure, a 3.5 error code. So I haven't taken a look at this. Let's take a look together and see if we can get this figured out. All right, the first thing we're gonna check is if it turns on. We aren't getting a light. Let's go ahead and plug in the power and take a look at keep your eye on the power meter here. Okay, we are getting current draw, all right, 0.47. So it is powering on, and we do have a power light, and we are getting flashes. So let's see if we can see what that flashing code is. It looks like 3 fast red lights and 1 blue. I'm not getting the 3.5 that they mentioned. Yeah, normally an error code's gonna be kind of at a slower pace. This is blinking really fast. So now we're just having a constant red blinking light here. So that's a little bit different, and the current isn't changing. So normally when the machine's booting up, it should change current, should go up and down, up and down. So this is not doing that, it's just flashing constantly red. So let's see if we can hold down the power button, see if it would shut off. All right, so I'm not getting it to shut off with that. So let's go ahead and open the bottom up and take a look inside. All right, the bottom is off. All right, let's take a look around. Like I said, this is one of the higher end machines that Dell makes. This thing is even shipped with a RTX 4090. I don't know if that's what's in this particular machine. So this one has 3 fans here, 2 main cooling fans, an extra one on the GPU. And then there's also a memory cooling fan in the middle here that blows over at the memory sticks, DDR5. And then there usually is a VRM cooler, but this must be the lower end version. I've seen it where there's an extra VRM heatsink that actually comes over to this fan. So this must not be the 4090 version. That might be a 4070 or something like that. But anyway, there's the main battery, Dell OEM. And in case you didn't know, my company specializes in Dell and Alienware laptops exclusively. So we actually stock pretty much every single part for every single model of Dell laptop. So if you need a part for your Dell or Alienware, you can order on our website and it ships same day. Everything you're gonna get is gonna be a genuine Dell part. It's gonna have a serial number on it. It's gonna have a year warranty. So support the channel, buy from parts people. Let's continue here. So what I want to figure out, we're going to go ahead and try a CMOS reset real quick. We'll unplug the main battery, and then I'm just going to press the power button. We want to see if it's going to do anything different. This will purge all the capacitors. We'll have a little bit of charge. This will purge all that power from there, so we can reset the actual CMOS, because sometimes you get a frozen BIOS. So now we plugged it back in. It turned on automatically, and we're going to get a blink code immediately. So we're still getting the 0.48 that we were getting before. And I'm waiting for the alien head here to blink. It may take a little second here, but if we are going to get that 3.5 error, it should happen after a little of the startup sequence. But one thing to be aware of on these machines, they are shipped with liquid metal on the CPU. And I have seen in the past that these systems, like if you store them like vertically, like in your backpack or something like that, you'll have leakage and it will leak out. There is a dam on the CPU, but sometimes it will leak out and get on some of the other parts of the board. So that is a possibility, but we're not seeing anything different by doing the CMOS reset. So we're gonna have to proceed by removing the motherboard, and then we can take a look around and see if we notice anything. So let me go ahead and take this board out. So what I'm looking for is I wanna make sure that nobody else is actually taking this apart, and I can look and see right now that the screws are not super worn out, which is a good sign. I do see a little bit of wear on this screw here. I could tell that the bottom case had been taken off, or the bottom cover. This doesn't look like it's been taken apart too much. It's hard to fix something that somebody else has been working on, so that's why I always look for that. I'm trying to collect clues just so I can figure out, like, you know, what I think the cause is, because if this just happened one day, whenever I get notes that just say, oh, it doesn't power on, 3.5 error code, it doesn't really tell me anything. It doesn't tell me, oh, I was in the middle of a game, or I spilt water on it. Sometimes they don't even tell me that. They're like, it just mysteriously doesn't turn on. But you have to collect clues to try to figure out why it's not turning on, or why it's getting a 3.5 error. And I haven't actually seen that 3.5 error yet. I'm just going by what the customer said. So we're assuming that we have some sort of missing power rail because of what they said. All we got was a fast blinking red Alienware headlight, which is kind of a weird symptom. It's not a normal symptom that you would get. It's funny. So someone had to take this apart because there was a screw in the wrong spot. That's pretty strange. All right, got the battery out. Let's unplug these latches here, ribbon cables. Okay, the board should just lift out now. All right, and the motherboard is out. And that was a lot of screws. Look at all the screws I just took out. All right, gonna load this heatsink. I mean, it literally covers the entire bottom part of this. And so we got the CPU and GPU. I think the GPU's on this side, CPU's on this side. And it covers all the VRMs. This is gonna be the 3 volt and the 5 volt power rails. Let's go ahead and check to see if those are present. So I left the DC jack plugged in. I'm just gonna plug in the power, and then we'll put this in voltage mode. And I'm just gonna measure these real quick. We got a 3.3, and we have our 5 volt. And then this one is probably 1.2 maybe, 0.8. And then there's another one underneath this heatsink. Let's see what we have on that one. That's 13.6, 12.8. And it's a negative because I put positive on the ground. So here, I'll reverse it for you. There you go, positive voltage. So 12.87. I'm not 100% if that's supposed to be correct or not. I think that's the battery charge circuit, so that's probably fine. So the machine still isn't turning on, and I don't know what's getting hot. I don't know what's taking that 0.47 amps. But what we can do, remember I was talking about how the CPU has liquid metal on it. We need to get this heatsink taken off, and we need to see if there's liquid metal that's spilled out. So that's kind of what I want to eliminate that as being an issue before I start spending a lot of time troubleshooting on this board. So let's get this heatsink off, and if there's liquid metal under here, which there will be, I'm going to clean it off, and I'm not putting liquid metal back on. I'm not okay with it. I don't think it's worth the hassle or stress. I've had more issues with liquid metal on these machines. So I have some TTM 7950. We can put that on there, and that will perform close to the same. All right, we're gonna be very careful getting this off of here because we don't want to have it leak. We're gonna rock it back and forth because it's gonna be sticky a little bit, and then we'll lift it off. Here we go. And there's no liquid metal on it. Whoa, I'm amazed. So that's a first. I guess they stopped putting liquid metal on it because they were having so many issues, because that was an issue that we kept running into, is that they kept leaking. This doesn't even have plastic covers on this. Normally there's like a plastic cover. Here, let me show you. I got a board right here. Yeah, look, this is another M16R1. This has a 4090 in it, so this is actually an RTX 4090. And you see how it has all this plastic cover around here? This is a dam because it actually came with liquid metal. The CPU dies, looks the same. It actually has this cover on here, but this is definitely a bigger GPU. This one doesn't even have plastic covers on it. This one does, so that's strange. I wonder why they changed that in their design. Okay, anyway, so looks like this heatsink cools the chipset also. Here's the chipset, and all of this looks good. Let's just get under the microscope. We'll look around and see if we notice anything, obviously. So we're gonna look for any burnt components or cracked components. So here's the VRAM for the GPU. I don't know which GPU it is. Not a 4090, we know that. There's a current sense resistor of some sort. I don't know which power rail that's for. We got 4 MOSFETs. This might be part of the input circuit. Here's another current sense resistor. This is that inductor that we measured the 12.88 on, so I'm thinking this actually charges the battery. These are probably in charge of charging the battery. There is the power management chip right there. And I like to identify things so we can figure it out. So we measured 0.8 here. This is going to be the EC chip. All right, and there's the BIOS chip. There's our 3 volt and our 5 volt, 3, 5. What else we got? So these are going to be the power stages for the CPU. Looks like there's 7 of them, is that right? 6? 1, 2, 3, 4, 5, 6, 7. Let's see what CPU it is. An SRM E5. So if someone can look that up and they can put it down in the comments. This is going to be the PD controller for the USB-C ports. That's the Thunderbolt controller chip. All right, I don't see any issues on this side. Let's take a look on this side. I also want to look for some water damage or something like that, some liquid damage. Sometimes that will cause these symptoms pretty quickly, but everything looks very clean. All right, here's the back side of the GPU. On that 4090, there's another set of power stages on the back here. Okay, well, we made our way around the board. I'm not seeing an issue. So we don't have anything obvious. We don't have that liquid metal issue that we were thinking. So if we just recap what we do know, we do have all of our power rails. I'm not seeing a power rail failure. I'm not seeing that as an error code. Let's plug it in one more time. I want to see if we are getting, what's getting hot here. Because that's what we need to figure out too, is what's actually coming on. See if I can just feel it. Feels like maybe, feels like this is coming on over here. GPU. Yep, this is hot right here for sure. We can look with the thermal camera real quick. Here's one of the cheap thermal cameras that I like to use. They're super portable. And the one I normally use is going to be a Flare 1 Pro. I hook to the bottom of my microscope, and then I have it mounted where I can look at it through my phone. But these are, I think, 140 bucks or something like this. I have links inside my description. You can get it. But just plug it in my phone, and it will boot up like this, and then we can take a look. So if you want like a cheap thermal camera, do it this way. All right, so it's not high resolution at all, but it gets the job done. This is actually what I started with. All right, so you can see this area right here is getting hot. And I think this would be the VRAM power. Power stages for the GPU are on, and then the CPU is cold. So it looks like only the GPU side's coming on, but the CPU is cold. So are we missing power over here? Over here's warm too. So what's that? Over here, oh, something's really hot right there. We might have a capacitor that's messed up right there. Let's get in there and get a little closer and take a look, because there's something very hot in that area. All right, so in this area somewhere, it's getting warm. I could tell that this was warm, but something else over here is warm. So I'm just gonna put some alcohol on here and see if anything evaporates. It might be on the other side of the board. It would be nice if it's just a capacitor. Well, this is getting hot for sure, that little chip. We're measuring it at 0.1. So to me, it seems like we might have a short in this area, because 0.1 is gonna be too low. Let's put it in continuity mode and let's measure how many ohms we have in this area. All right, so we have a short. All right, so here's gonna be where our issue is. We're measuring almost a dead short on this coil. This is gonna be the output coil. Now, sometimes you'll have low readings on coils like this whenever they're powering something like a chipset or a CPU or GPU. Those are gonna be really low. So it's measuring a dead short to ground. So the odds that we have an issue with a bad or cracked capacitor has just went up. So that's what we're gonna be looking for. I think it's gonna be in this area somewhere, but we're probably gonna have to use voltage injection. Let me go ahead and take these memory sticks out. I'm gonna look on the other side of the board over here, see if we see anything noticeable. What I'm gonna try to do is I want to be able to see if we could fix this without having to use a lot of fancy equipment. I know a lot of people don't have all that. And so the basic way is to kind of do a visual inspection, see if you see anything suspicious, right? Different color or cracks or things like that. We did use the cheaper thermal camera, and that will, it is a tool that does help identify something. So let's zoom in a little bit more. I want to examine these capacitors here. Do any of these capacitors look messed up? No, I'm not seeing an issue with any of those. I mean, this chip could be shorted itself, but usually whenever I have one of these getting hot like that, like it's shorted, it's usually shorted on the output, and we measure the output being shorted. Now, that's not to say that this chip is not bad, but I'm not going to just jump to the conclusion and say, hey, that's what we need to be replacing. That's not usually how it works. So, all right, let's go ahead and let's inject a little bit of voltage in here, a little current. And we're gonna do it right here at this point. And so the idea with this is whatever's shorted to ground, if we inject some current in there, then it will actually get hot and it will show us what's actually causing the issue. So we are going to set our power supply to we're gonna do something kind of low to start with. So we'll do like 0.8 or something like that, 0.7, that's fine. And I'm gonna hook it on the ground. And I'm not gonna use the thermal camera at this point. We're just gonna, ooh. So I'm going to turn it down just a little bit more. We don't want it too high here. Okay, 0.6 now. 4 amps. Okay, we'll go down a little more. 0.4. 3 amps. Okay, so something's going to be getting hot. So what is it going to be? So I'm going to put a bunch of alcohol over this whole area. And then we will put it in there. I don't see anything happening. Tell me if you see anything. Oh, I think I see it. Here, let's try it over again. You see it? You have to look closely. It's hard to spot, but you have to pay attention closely. I'm going to put more alcohol on here. Here we go. You ready? Do you see which one it is? Can you tell? Let's try it again. Put your answer in the comments right now. I think I know which one it is. This one. If you guess this one, then I think you're right. So I think this is the one that's shorted out, and it's shorting straight across the ground, and we can confirm that that's actually a shorted area by measuring across it. 0, 0. So I guarantee that on the back side of this thing, it probably has a crack on it or something like that. One more time, you want to see the alcohol trick? So we're just putting a bunch of alcohol on here, and then I'm going to heat it up. And we can add a little more current now that we know that it's safe. So now I'm up to 0.7 volts, which will do us about 4 amps. Boom. Look at that bubble. Look at it go. It's like a geyser. Love it. I'm gonna do it one more time. There she blows. All right, so are we still thinking it's that third one right here? Are we still thinking it's this one? Yep, I think so. All right, so all we have to do is replace that capacitor, and then this board should be good to go. So first we're just gonna remove it, and then we will get a new one put on. So let's go ahead and get that set up. We'll start with the soldering iron and see what we can come up with. I'm gonna protect that RAM slot real quick with some capped on tape. This is some high temperature tape, and I actually bought the 2 mil thick, so it's extra thick. And I use this to protect any of the components. All right, so I'm just gonna put it on the edge right here. I just don't want to accidentally touch the soldering iron to the edge of that. It's not the end of the world, but we want it to stay looking pretty. All right, so what did we say? It was this one right here? So we'll see if we can get that one taken off. So what I'm gonna do is I have my soldering iron here, and I'm just gonna try to tombstone it, which is where you lift up one side and just kind of walk it up. So we'll see if we can get this thing lifted up. Let me turn on my air so I don't die from all the lead poisoning. So I'm kind of lifting it up and applying pressure and heat. There we go, it's lifting, there we go. Got it up. So, let's just take the other half off. I'm just gonna keep heating it here. And we're off. All right, so we got this one off of here. Let's see if the short is gone. So we're gonna measure back here at this inductor, this power supply. And what are we measuring? Not 0. So we got it fixed. So all we have to do is just replace that capacitor with a new one. The board should actually run fine without that one, but it's always good to put it back the way it was in factory. So What I don't know what value this is, and without like a schematic or a board view, it's not going to tell you. So, but because these are all the same in parallel, we're just going to pull one off. We're going to take a look at it, and then we will get that value, and then we can replace it. So this time, I'm actually going to try some hot air to see if I can just remove it. I'm just going to blow the air away, and we're just trying all different techniques. So I can just kind of show you different ways of handling different things. So I'm going to use hot air. I'm going to pull this away and just kind of tack it there, so that way we can measure it, and then we'll put it back. I'll probably just put it back in this spot so then I can replace that end one. So I'm going to use a lower air pressure and a lower heat. So we're at 400 degrees C, and we're at 40% air, I think, 42% air. I'm going to try to just heat this area a little bit. And I'm blowing the air away. I'm being conscientious of that. And it started to melt. I know you can't see because I can barely see what I'm doing because I'm trying not to blow it on the memory slot. So, okay, so I got that off. I'm just going to tack it right here so we can measure it. That was a pain in the butt. Yeah, hot tweezers would definitely be useful in this situation. Okay, let me measure this real quick. We're in capacitance. And we can measure that at, was that 25 microfarad? Yep, close enough, 25 microfarad. So let me go ahead and we'll get a 25 microfarad and we'll get that installed. I'll just move this one back right now. Should we go back to trying to use the soldering iron? Give up on the soldering iron. Perfect. Okay. All right, we can install the new one. Okay, we got that replaced. Let's get the area cleaned up real quick. We did the best we can in a tight space. We definitely didn't want to melt these connectors, and it looks like I did do a little bit of damage on the corners. I was blowing the heat away, but there's really not much I could have done. It was tight space. Even with the soldering iron, I would touch the edge there. Anyway, let's go ahead and plug in the board and see if we have our voltage there now. So here's the coil. Let's plug it in. And we're getting 5 volts. Okay, so we do have a 5-volt power rail here now. And let's see what the board's doing. So let's see how many amps the board's pulling now that we have that shorted power rail fixed. And it goes 0.42. Interesting. It's doing the exact same thing it was doing before. And we did definitely have a shorted power rail there, so I'm wondering if we have another shorted power rail somewhere else. Let's see what's getting hot real quick. So this whole area is going to be hot because we were just changing out those capacitors, but I just want to see if anything else is getting hot. So we have this getting really hot over here, and then it looks like the GPU coming on again, and the CPU is still cold. So this is a strange one. With that short on there, it should have resolved the issue. We definitely had a cracked capacitor. You saw that we were, injecting the voltage we were shooting there. We resolved that issue. Now we actually have the 5 volts there. So I'm not sure what's going on with that, but it's getting late, so I'll continue this tomorrow. All right, it's the next day. Let's continue looking at this board. So we did find that shorted capacitor on that 5-volt rail. And so now that we've resolved that issue, let's see if the board turned on. I believe that when we plugged it in yesterday, it was still doing the exact same thing. So let's take a look at the current. When we plug it in, we should see it start pulling current and heating up the CPU and GPU. So now we got to figure out why the CPU still isn't coming on, because remember that current is being pulled is only on the VRAM and this the GPU side, but we're not getting any power to this side over here. And that short we had was over here in this section, which would be on this section, And does it tie into this at all? I don't know. I don't have a board view. I don't have a schematic. Hopefully, maybe I can look around and see if I can find one. This is a newer machine. A lot of times it's harder to find things for that. So at this point, I actually have no idea what's causing this issue. And we're just gonna have to kind of keep messing around, and I'll keep looking around. Actually, one thing I didn't try, I didn't put any RAM in it. Let's put some RAM in it. Maybe it needs RAM in order for it to get past that boot sequence. Let's try that real quick. But I believe that it was pulling 0.4 whenever we first got it too. 0.45. Yeah, it's still not getting past that. So it's not like it's a boot sequence thing. Hit the power button, does nothing. If I hold down the power button, does it shut off? Yeah, it's not even shutting off with them holding down the power button for 10 seconds, 15 seconds. So yeah, we definitely have some sort of other catastrophic issue, and a shorted capacitor caused some other big issue, or the shorted capacitor is a symptom of what had happened. You know, it doesn't really make a lot of sense to me, because the current draw that we were having is the same before the capacitor was changed out and after. So I don't know exactly why there's something else that's not turning on. So I'm gonna have to keep looking around. I'm actually pretty surprised that this isn't coming on. So it's pretty interesting, because the fact that the board was pulling 0.4, and then we had that shorted capacitor on that one power rail, which the power rail is right next to the RAM slot, and so it ended up being a 5-volt power rail that actually powers these DDR5 modules. And so we resolved that issue, and every other power rail's there. So why is it not coming on? But you know, another thing, I'm trying to collect clues here, but another thing that I did notice is that when you hit the power button, it doesn't respond to power button inputs. Normally, even if you have a board with that has a bad power rail and it's coming on and then giving you a power rail failure, you could hold down the power button for 10 seconds and the machine will shut off. Well, this machine even has a power button on the board, but no matter what you do, it will never shut back off when you hold that power button. So to me, I'm starting to think that this may end up having a bad chipset or a bad EC chip. The EC is actually what communicates directly with the power button. And I was trying to look into seeing if I could program this chip. This is a different type of chip than I've programmed in the past. And the program headers are here off to the side, but I don't think that my chip reader can actually program that. And I think it might actually just be a bad chip altogether. So that may be an option. I don't really know. But the other thing I'm noticing is that the chipset's not coming on at all, or it's not getting warm at all. We are getting power to the chipset, but it's not coming on. So whenever we look under the thermal camera, we are seeing this whole side getting hot because it's the GPU section that's getting hot. We see the EC chip come on for a moment and then shut back off, and then the chipset never comes on, the CPU never comes on. So with all these symptoms on here, it's probably going to be a bad chipset or a bad EC chip. I can see about ordering one of these EC chips, but I can't find one in the United States, so it's going to take a while to order one, and I'll have to get it from China or something like that. And then it will still need to be programmed, but I can't program them, so I don't know what the solution is for this. Actually, I ended up messing with this board a little bit more. So I figured out that on this system, so if we plug this in right here, you know, we get our 0.4, and it just sits there and does nothing after that, right? And the CPU is not getting hot. I've charged their battery up because their battery was actually dead. And so when I plug their battery in, and then now I'm going to plug in the power, 0.4, and then it jumps up to 1.85, and then that CPU is getting hot. And so I haven't had the CPU turn on this entire time. So let's get this reassembled and test, because this should be working. So maybe it just needs to be fully reassembled with all the parts installed. A lot of these boards, I could just plug them in. We'll do a whole boot startup process, but maybe these are operating a little differently. We'll get some fresh thermal paste on here. All right, the motherboard is installed. Let's go ahead and test it. All right, let's keep an eye on the power meter. 0.4832, that's good. We got a power light. We got the backlight on the keyboard's lit up. All right, just sitting there though. Is this charge current or is the CPU on? It's going to take a little longer for the first time where it boots up, so it's going to have to go through a whole startup process, but the fact that it's just hanging at 2 amps, I don't like that. So let's see what we got to do. Let's see. I'll give it a little more time though. It does respond to the power button presses now. It wasn't doing that before. Turn it back on. It just goes straight to that 2 amps. I don't hear the fans coming on either. 262, 205. 3, hey, that's higher than normal. Do you see it jump up to 3.72? But we aren't getting the fans, we aren't getting anything like that. Okay, 2.3. And we got an Alienware screen. Yes! Oh man, I was worried about this one because it was strange. So like, you know, we ended up having a capacitor that was cracked on the power rail that powers the RAM, okay? We changed that out, and then we still had the same symptom, which was crazy. So I guess there must have been some sort of surge that went down the line because no matter what we did, it was pulling that 0.4 amps like it was dead. So now everything is back up and running again. Let's put an SSD in there and see if it boots to Windows. All right, I got their hard drive installed. I'm just going to check to make sure it boots up to Windows. And this message is because I don't have a big enough charger, it doesn't matter. We're just trying to boot the Windows. So it's not going to be putting it at full while I'm just trying to boot it up real quick. And look at that, we got it booting the Windows. So, all right, we successfully made it into his Windows operating system. It looks like this one's all fixed up. This one did trick me a little bit, but if you like this one, I'd love to know your thoughts in the comments, and thanks for watching.
I saved another laptop!